So now let's do another example, but this time it's different because we have different proportions. So what does that mean? Well, in the previous two examples that we saw, the proportions were the same. So there was no difference in this, but now the proportions are different. So a statistics teacher claims that on the average, 20% of her students get an A, 35% get a B, 25% get a C, 10% get a D, and 10% get an F. The grades of the random samples of the 100 students were recorded. Test the claim that the grades follow the distribution claimed by the teacher. At the 5% level of significance, is your claim true that the student's grade followed the distribution given? Okay, here's my grades. So I need to make my hypotheses, and it's not really difficult to make these. It's a little bit different than the equal, but all you're going to do is for your null, you're going to state what you were given. I do have to convert the percentage to a proportion, but that's easy. Really, all you're doing is taking the 20%, moving the decimal places 2 places to the left, and then you get your proportion. So my null is that the proportion of A's equals 0.20, proportion of B's equals 0.35, proportion of C's equals 0.25, proportion of D's equals 0.10, and proportion of F equals 0.10. All right, that's all you have to do for the null. Again, it's a P for proportion, and then the letter below it is for the letter grades A, B, C, D, and F. If I had like days of the week, I could do the proportion of M equals the proportion of T. You can make those little subscripts, whatever you want, so that you can explain to yourself and the reader what they stand for. So the alternative is the proportions of the expected values do not fit the proportions given. So this is important. There could be differences. I can't run this test to show the differences. This test just shows me, hey, there's a difference. So that's all I'm looking for. So let's go to Minitab. And again, if you look at the stuff given, I want you to see that I have the directions in the PowerPoint. So I'm going to go to Minitab, and I've already started working on this. So I have 2 columns here. Don't worry about the first column. Just go where I have some grades. And what I'm doing this is I'm saying summarize grades. I just shorthanded it. So I'm going to do A, B, C, D, F. Then here's my observed grades from that table I gave you. There were 29 A's, 42 B's, 20 C's, 5 D's, and 4 F's. Here, all I want to do is I want to put my expected proportions that I put in my null hypothesis. So 0.20, 0.35, 0.25, 0.10, and 0.10. So I go to Stat, I go to Tables, chi-squared goodness of fit. So what I want to do now is I want to do observed counts, and I'm going to clear it out so you can see what I did. I'm going to do observed counts. So I'm going to click on grade observations, and then I'm going to do here categories names. I'm going to do some grades. Make sure you know exactly what you want to do so that can help you. I'm going to hit I'm going to hit proportions, and then I'm going to do by input column. All right. You might have seen some other stuff I was doing. I'm going to show you in a minute why I did that other stuff. But this is what you want to do when you have put your summarized data in. Again, summarized data, they gave it to me in a table. So I want to change proportions specified by historical counts, and I want to do input column. What that does is it says, okay, go to this, I'll show you. Go to this part of Minitab and get me this column. So if I click in it, then I'm going to go do my expected. I made it easier on myself by labeling observed, category names, and my expected. I hit OK, and look, it gave me everything I needed. Here's my categories, here's my observed counts, and here was my proportions. The other thing it does for me is it gives me the expected values. I don't even have to do the math of it. But if you're curious where that's coming from, I'm going to go back to the PowerPoint. And if you look here, for the A's, I have my sample size, which is 100, and then I multiply it by the proportion. So 100 times 0.20 is 20. And again, don't do that by hand. Minitab does it for you. So if I go back to the PowerPoint, here, let's do it for the B's. So 100 times 0.35 gives me 35. And I can do it all the way down. The expected, if I add it together, will be 100, which is the same as my observed. Again, I'm comparing my observed to my expected. I get my contribution to my chi-squared, which is that formula we talked about in the beginning. Sample size was 100. Degrees of freedom, remember, it's not always going to be 4, but degrees of freedom is number of categories minus 1. Again, 5 categories minus 1 gives me 4. Chi-squared value is 12.55. P-value is 0.014. All right, so that's how I did it for summarized values. And if I keep going down, it gave me my graph. And now remember, my expected values are different. So that's why my orange aren't all the same across. And then my observed are different. And what we do with chi-squared is we see if the observed and the expected are doing what we want them to do. Right. So let me go back to the PowerPoint for a second and do something a little bit different. I'm not going to talk about what I've gotten yet. I'm going to keep going because I've just shown you everything. But now, what if I have raw data? What if you weren't given the summarized data, but you were given this hot mess of a data and you're like, I don't know what to do with it? Minitab makes it easy for you to handle. And think of it this way. If you're given an Excel file with a ton of data, do you want to have to make a frequency distribution and count up all those counts for each category? You might have 10 categories. You don't want to do that. Minitab makes it really, really easy for you to handle. So I'm going to go back to Minitab and look. In my first column, if I scroll down, I have all the grades that haven't been summarized. It's just the raw data. It's easy to do in Minitab to do it. And again, if I go to the PowerPoint, I walk you through how to do this. Okay, so let's do it. I'm going to show you how to do it. I'm going to go back to Minitab. I'm going to go to Stats, Tables, one variable. This time, I'm going to call it categorical data. Why am I calling to categorical data? That to me says, okay, go find my raw data. So then I'm going to click on my raw data. Why? Because remember that first column of grades is all my raw data. Excuse me. And then from here, what I'm going to do is I'm going to change I'm going to click on proportions and do the constants. So here, remember, A's were 0.20, B's were 0.35, C's were 0.25, D was 0.10, and F was 0.10. So I put that in and I hit OK, and I run it again, and look, I get the exact same values. That's it. It gave me everything that I had gotten in the previous one. If you want to see your previous one, just click back here and it gives it to you, and they're all the same. So that was great. There's 2 different ways to do this. I could give you summarized data or I could give you raw data. It doesn't matter. They're both easy to handle. So again, I have the instructions in Minitab, but let's go conclude. All right, so here we go. All right, so I can see that I have a chi-squared value of 12.55 and a p-value of 0.014. So I need to compare my p-value to my level of significance. And again, my level of significance was 5%, which equals 0.05. Okay, p-value versus level of significance. If you get confused, just add that other 0. Why? Because it's easier sometimes to see your decimal places in equal zeros. So here we go. 14 is less than 50, so I reject the null. So if I keep going, again, I rejected the null. So that means my null is not correct. So I feel like my alternative is true. So what does that mean? The proportions of the expected values don't fit what the proportions were given. What does that mean? So the teacher was unfortunately incorrect. Even though she had a hunch and the grades kind of looked that way, they didn't follow the distribution. But with this test, you cannot say which were the differences. You can speculate, but there's other tests that we run that we're not covering in this class that could show you, oh, here's the differences. So what can I conclude? At the 5% level of significance, the student's grades don't follow the given distribution. The teacher wasn't correct that her grades follow that distribution. So I've closed the loop. I've answered my questions based on the data. And again, you saw the data as summarized or as raw.